Oh my goodness. Okay, anyways. Normal CDF and inverse norm. And I guess I'll tell you right away how you would find those functions. Okay. Second, vars, and then you see those functions. So let's just quickly do that, get it out of the way. So you press second, and then vars is right here under the arrows. And you should see normal CDF, very important, and inverse norm. Those are the only two that we're going to use in this course. Okay, normal CDF and inverse norm. So second vars is how you get there. Okay. So in some cases, you will be asked to calculate the percentage of data between two values that do not appear on the sketch of a normal curve. Okay, so these values that I would be giving you would not appear on the sketch, so then you can't do it. You can't guess. Do not guess, because it has to be specific, right? So let's start with normal CDF, right? This is what it needs. You need to feed it a lower limit, comma, upper limit, comma, the mean and the standard deviation. There. So what does this do? We'll calculate the likelihood, right, or the percentage of values between below or above a given data point or data points, right? So I will write a note here. If asked to find percentage I will just do this, hold on. Instead of percentage, I'll say probability below value we use minus 1 million as our lower limit. And I'll explain that a little bit more later. So that was one case, and then if asked to find probability above value, we use 1 million positive as our upper limit. This is all in a cloud like this. I will say this answer is given as a decimal, multiply by 100 to get percentage. So I want to tell you this though. The negative 1 million and the positive 1 million works most of the time. But if you are dealing with millions of dollars, you need to go 10 million or 100 million, whatever the case is. You need to make it as small as possible or as big as possible considering everything. Okay? Inverse norm. This is actually how the calculator shows it. And what it needs is percentage of data to the left of value. It needs to be as a decimal. And then mean and standard deviation next. So these are the three. It only needs three things to be able to work it. Okay. We'll return the actual value that we are looking for. And this could be centimeters, feet, percentage, dollars, number of people, etc. Okay. Once we've written this down, I'm going to start a new page. I will actually graph a bell curve, and we'll also use our calculators to find out the exact amount. And so again, why is normally distributed data important? Well, we can make predictions if we see that it follows that pattern, right? That's basically what it comes down to. They use this kind of thinking all the time when making decisions, okay? So here, example, potato chips come in bags with a mean weight of 250 grams. and a standard deviation of 5 grams. Sketch. We'll sketch a normal curve. I won't make it too fancy, okay, because this question is not about that. So we're going to go all I'm going to do here is I'm just going to eyeball it, okay? So this is 250, and then I'm going to go 1, 2, 3, and I'm going to go 1, 2, 3 to either end. And I'm going to, in this case, I picked a nice and easy standard deviation. So this is 255, 260, 265. And this is the weight of the bags, right, in grams. Okay. Here we would go down by 5, so 245, 240, and 235. And remember, the standard deviation tells you how spread out data points will be. The bigger your standard deviation, the flatter your curve will be, more variety, more inconsistencies. The smaller your standard deviation, you're basically compressing this, right, and making it smaller. So I go to the top here and I just go like that, and then back to the top, and I try to copy it as best as I can, and we're just gonna write down our values real quick. So nothing fancy, okay? 34, 34, 13.5, 13.5, 2.35, 2.35. And I will just say this. For illustration only, okay? We're going to use our calculator to actually figure out the exact values. And I want to introduce something called a z-score. So we're going to add that here. I will talk about it a bit more later on. What are z-scores? It basically just tells you how many standard deviations away you are from the mean. Okay, so write that down right underneath. So if the z-score is 0, you're basically telling me that you're right by the mean, you're right by the average. If your z-score is 1, you are 1 standard deviation to the right. 2, 3, right? So the z-score tells you how many standard deviations you are away from the mean. Therefore, if you are to the left, you would have a z-score of -1, z-score of -2, and z-score of -3. So I can tell you, it can tell you this, how many potato chips will have a mass between 245 and 255. That would be 68%. Or I could ask you, how many potato chips would there be if they have a z-score of -1 and +1? It's still 68%. We're talking about they correlate, okay? So here we go. So for A, calculate the percentage of bags weighing calculate the percentage of bags weighing between 232 grams and 273 grams. again, I need to reword this, but we can't just write indefinitely. It's also saying what's the probability that bags will be weighing between 232 and 273. It's the same thing. What's the likelihood that bags will be weighing between this? So you should note that 232 is nowhere in our graph here. It's not there. 273 is not on our graph. So we have to redo this one. We have to use our calculator. So we go normal CDF because they want the percentage of bags. So that's normal CDF is the only one that can do that. So we go lower limit to upper limit, which is 273. And our standard mean is 250. Our standard deviation is 5. And we multiply this by 100 to get our percentage. Okay, so follow me with your calculator now. Let's quit. I'm going to quit, so I'm going to go second vars, call normal CDF, okay, the second option, and then just type in 232, 273, 250. Always use commas in between. If you don't, it will complain if you make a mistake. And so we get, I will write that down here, 0.9998 right, times 100 would give me, so you multiply that by 100 or shift the decimal 2 places, 99.98%, almost 100%, right, of bags would be there. And you could confirm this by looking at your graph. If you go back up here, 232 would be like outside here somewhere. And 273 is past this end, right? So we are actually spanning the whole thing almost, but not quite 100%, right? B, percentage of bags heavier than 257 grams. So in other words, this is, I'm going to rewrite this. In other words, bags 257 grams or heavier. Right? That's what this question is saying. And again, they want percentage of bags. So when that is, you got to use normal CDF. Normal CDF, would 257 be my lower limit or my upper limit? What would you say? If it's 257 and heavier, then it's my lower, yes. So that's where you need to think, like, where does that upper and lower thing go, right? And I don't have an upper limit, right, really. I just want 257 and heavier, but normal CDF needs something that's really, really big on the other end. So that's where we go 1 million. Just think of the fact that you would like $1 million, right? And given the 257, 1 million takes care of it for sure, right? And then our average is 250, our standard deviation is 5. We're going to multiply that by 100. So you can, if you want to, you can just go copy your previous entry. I always just like to retype it, like just go second trace, not second trace, second vars. Oh, what happened there? Let's try this again. Second vars, normal CDF, 257, comma, 1 followed by 6 zeros. And then it's 250 and 5. Hit enter. What happened there? Oh yeah, you saw my mistake, don't you? You're laughing. That's all good. I put in 25. It's 250, comma 5. Close the bracket. There we go. So it's 0.0807 dot 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 times 100. Use all the decimals, right? And so it's 8.08%. of bags you are expecting. That's the likelihood of that happening. Okay. C, percentage of bags weighing less than 242.5 grams. So because, okay, this is how I want you to think. Okay, it's asking me for percentage of bags. This number is nowhere to be found on the sketch, and Mr. Dirksen didn't ask me to sketch in the first place. I will use my calculator. The only function that can do this is NormalCDF. Okay, so it's almost like a no-brainer. You want bags that weigh less than 242.5. So in this case, 242.5 is like your upper limit. Does that make sense? It's my upper limit. So I'm going to go minus 1 million and put down 242.5 followed by mean and standard deviation like that. I'm going to multiply that by 100. And I'm just going to go second vars. I'm going to go NormalCDF minus 1 million. That gives me 0.0660. It keeps going times 100. You can just shift the decimal at 6.68, right? So that is the likelihood of that happening. Okay. I will give you a diagram for this one. 242.5. Let's go find the approximate location on our curve. 242.5. I would put it right there, wouldn't you? Right between 240. It's right here. Do not think that it's half of 13.5. Because look, this is a little bit bigger. This section is bigger than this section. So you can't just split that in half and do the math that way. But it's here or less, right? So technically, 242.5 is right here. And you want everything that's to the left of it. So that's where the minus 1 million comes in. You're just picking something so small on the left here because the NormalCDF needs a lower limit. It cannot do without. So that's what you did here. Okay? And so you found that this is 6.68%. Okay? That's what just happened there. Are you able to squeeze in a graph here? I don't know. But 257, I'm just going to go check up here. 257 is right about there. Right about here, I would say. So if you want a graph, you would say this is 257, and all of this is what you're after. So this is plus 1 million on this other end. So the 8.08% is represented by that sliver there. Okay. So this is where you find what's lower than something, and this is where you find percentage that fall above it. This could be the same thing with your score on a test, like what's the percentage of students that you think scored above you, how many scored below you, and all of this can only be done if it's normally distributed. You can't just do this if it's any set of data, right? So if you graph it, it should look like a bell curve. Let's do a couple more here, or at least D. This is where Z scores come in. Percentage of bags between Z-scores of negative 2.5 and 1.8. Percentage of bags with a z-score. If I talk about z-score, let's think about this. What is my mean in that case? What number goes with mean if you go back to the curve? 0, right? So my average is 0, and my standard deviation is, how much are you going up by to the left and to the right? 1, right? So you're almost saying, I'm not here anymore. I'm going to go over to the z-scores. I wish I sound like a German teacher, right? Z-scores, right? That's where you're at now. So let me say this. If you see the word z-scores, you should automatically, first of all, you're gonna think of what I just said, right? You're gonna laugh, and then you're gonna be like, automatically, I know that my mean is 0 and my standard deviation is 1. No units ever. Z-scores do not have units. Okay. So can I use normal CDF? Apparently, at first glance, not. But yes, you can, because normal CDF is going to be negative 2.5 and 1.8, and then you're going to go 0, 1 times 100. So let's try that. Clear. Normal second vars, and they go negative 2.5, 0, comma 1. Sorry, you can't see that on the screen. There it is, right? I hit enter, and then I go times 100. So that would be, it's okay to just write 95.79% of data points. So let's say you make a mistake. It's a test or quiz AC, and you get this part right, but you put in 250 and 5. I don't think you're going to have a lot of luck. Let's try that. Negative 2.5, 1.8, then you go 250 and 5, 0, right? So you know something is wrong. Can't do it, right? These values are too small if 250 is your average, right? So you have that. We have 10 minutes. I'm going to continue. ABCDE, percentage of bags with a z-score of 2.95 or greater. And I'm going to go a little bit faster here, because I think you get the point, but you should at least have a pretty good sense of what I'm talking about at this point. If your z-score is 2.95 or greater, this is my lower, right? This is the lower. So we're going to go 2.95, and we're going to go 1 million, right? There we go. And then what's my mean? 0. And my standard deviation is 1. Why? Because of z-scores. Okay. Okay, so second vars, normal CDF, 2.95, 1 million. Really 100,000 would do, to be honest, but just stick with 1 million, right? So that is 0.16, right? Percent. It's a very, very small percentage that would be in there. And think about it, positive 3, your 3 standard deviation, if your z-score is 2.95, you're almost at 3. You're almost at 3, just a little bit before 3, so that's where it starts adding up the percentages. We see F, percentage of bags with z-score of negative 0.8 lower, or a z-score of negative, right, less than negative 0.8, normal CDF. In this case, this is your upper, because you want to go this or lower. So you're going to go minus 1 million, negative 0.8, 0, 1, because we're talking z-scores. And then it's 21.19 if I multiply that by 100. Boom. I need you with me a couple more examples, okay? Hang in there. Inverse norm. So now we're going to use inverse norm for the following. Oh, ABCDF. There we go. We're continuing from the potato chip bags there. What weight would result in 45% of bags weighing less? What weight would have, like what weight would you have to have as a bag where 45% of bags weigh less than you? And I would like to use just a sketch, okay? If this is your normal curve, you would have to agree with me that in the middle you have 50 to the left and 50 to the right, correct? So the value we're after is slightly over to the left, right? So this is the value we're after, right? And so we would have 45% to the left, and how many would we have to the right if this were the case? You can do it. 55, right? If 45 are to the left, 55 are to the right. But this is the one inverse norm cares about, not this one. Cares about that one. So inverse norm, it cares about the 0.45, which, by the way, they gave you that already. And then you just type in 250 and 5. No times 100. You do not multiply this one by 100. So this is left. This is right. Is it left, right? Oh yeah, just making sure. There you go, right? 0.45. Use your calculator. Second vars, inverse norm, which is the third option. We're going to type in 0.45, comma, 250, comma, 5. And so the weight that this bag would have to have is 249.37 grams. Always 2 decimals when finding that. So you basically figured out that this has to be 249.37. Right? You figured that out. One more. H. What? This will be the last one. What weight would result in 80% of bags weighing more than it? And again, when it's a question like this, they're not asking you for the percentage of bags that would be between here or way more. They're asking for the actual weight. Okay? You want to use inverse norm. But before you do that, please do this for yourself. Make one of these and just do a little curve like this. If 80% would weigh more than you, where would you think the value would be located? Here, 50% of bags would weigh more than you, right? So you would have to go lower, somewhere in here, right? This is the value you're after, and 80% would be weighing more than you. So how many would weigh less than you? 20%. And this is the one that inverse norm cares about, not the one to the right. It wants to know the percentage to the left. So you have to do this, right? So you go 0.2, 250, 5, right? This is left. That's what it cares about. So let's do this quick before we inverse norm. 0.2, 250, 5, 245.79. And this is actual in grams. So always watch what the units are that you are given. Okay. Okay. So let me just figure out which questions I would want you to do. You have to wait for the 5 minutes anyways, right? Just give me 1 second here. I want to make sure that what I taught today is in the homework, so I will post it on Google Classroom. Is that okay? Okay, so I'll post it there. Textbook, okay? Make sure you check the answers.